Hey all, I'm going to go over the Chapter 12 review paper version from your workbooks. This is covering everything we have learned in Chapter 12 on geometry. So first, which words describe this shape? Mark all that apply. As you remember, shapes come in many categories and there are many attributes to them, so we have to figure out what the conditions are for that particular shape. So in this case, we want to look, first of all, it is a closed shape. It is a closed shape. There is nothing open about it. So this one is not one of our choices. This is a polygon. There are no curves. It is flat. So we would mark A. Pentagon or quadrilateral. This is a four-sided. This is a five-sided. It can only be one or the other. In this case, we have 1, 2, 3, 4, 5 sides. This one has to be a pentagon. It's not a quadrilateral. It can't be both. It can either be one or the other. All right, let's move on. This shape right here, Umberto drew one side of a quadrilateral with 4 equal sides and no right angles. Well, I do know one shape that has 4 equal sides. That is a square, but it has right angles. So this cannot be a square. However, a square is also a rhombus, and so this shape must be a rhombus. So I'm going to want to go down, up, and down, and I have now added 3 sides to this shape. These 3 sides are all equal in length, adding to the 4th one, which is equal in length. So this rhombus is the shape that Umberto was trying to draw. I have drawn the other 3 sides. These can be a little tricky because you might not see which way they want you to go. Usually they're going to give you a hint by putting it in one direction or one area. You're going to use the other space because you could want to maybe go this way and think, wait, I want to go here and I want to go up. But you're trying to make it look like a regular polygon in these cases. All right, number 3. Mikhail saw a painting that included this shape. So this is the shape we are looking at right here. I can see that it has 2 right angles, and it has what appears to be an angle smaller than a right angle, which would be an acute angle. And it seems to have one that is larger than a right angle, because if it were a right angle, the line would be across the top here. I would see this, but this appears to be going bigger than this line right there. So this angle here appears to be obtuse, which means bigger. So now that I've looked at the shape, now I can see what types of questions they're asking of me. So let me bring this up. The shape has no right angles. Well, that's false because I see 2 right angles right here. Those are 90 degrees. False. The shape has 2 angles greater than a right angle. No, I only see 1 bigger than a right angle, so that's false. The shape has 2 right angles, 1, 2. I say that is to be true. And lastly, the shape has 1 angle greater than a right angle. Yes, because this is smaller, this is bigger, and I see 2 right. That would also be true. So in this case, 2 false answers, 2 true answers. All right. I want to keep us moving. Fran used a Venn diagram to sort shapes. Let me pull this down here for you. Okay. Draw another plane shape that belongs inside the left circle of the diagram, but not in the section where the circles overlap. Well, that means I need something that would fit in here, but not in this section right here. So I want it, I'm going to look at this. I have to have it have right angles, but it cannot be a quadrilateral. So it belongs inside the left, but not in the section where they overlap. So let me draw a shape with a right angle. And now I do not want it to be a quadrilateral, so it has to have at least 5 sides to it, or 3 sides. And I have 1, 2, 3, 4, and I can connect that. This is a pentagon. It has at least 1 right angle. I could say that it has 2, that would still be okay. And it would fit in this area here, but it would not be a quadrilateral. How can I describe the shapes in the section where the circles overlap? So this pink section right here, how can I describe those? I can describe those as they are, sorry, it's not showing up as well. I'll just give up and go with black. They are quadrilaterals with right angles. Okay, so that's the part that would be right in here. These are quadrilaterals with right angles. They have both conditions here and here. Those are always a little tougher because you have to look at both circles. How do they match up? Remember, you're looking at one circle or the other circle and finding out what are the conditions, what are the attributes of those particular shapes. All right, moving down to part B. Oh, sorry, number 5. Match each object in the left column with its name in the right column. Okay, well here we have 2 arrows as endpoints. And with 2 arrows as endpoints, that is in geometry, that is a geometric line. So that one would go to line. I also have one with points at each end. That would be a line segment. So I'd bring that down here to line segment. The one below that, we have 1 endpoint and 1 line. That is going in only one direction. That is a ray. And finally, we have this little guy right here. They're actually looking at this right there. That is a point, just a single point. So we would draw from here up to point. This is how this would look, matching each item in the left with its definition in the right. And as we move down, describe the angles and sides of this triangle. Well, I can tell that all the angles inside of here are less than 90 degrees. These are all acute angles. This makes this an acute triangle. That is bonus. The test is not going to ask you if it is acute or not, but it is less than 90. So all angles are less than 90 degrees. As for the sides, I can't necessarily measure all these, but I can tell that these 2 sides seem to be the same length. So I would write that 2 sides appear to be equal in length. I would put that 2 sides appear to be equal in length. If they had written that on there, then I would know for sure they are equal, but I have to assume that they appear equal. This line here might be the same length as those, but it doesn't look exactly. It looks a little short, and so that would be my guess. Okay. Let's move on to number 7, 8, and 9. Number 7, which words describe this shape? Mark all that apply. All right, now this falls into many categories. We know by looking at this shape that it is a square. So I'm going to mark square right away. However, we need to look more carefully because just like we've learned, these shapes can fall into many categories at a time. This one is also a polygon. So I'm going to mark polygon. Oh, it's not there. All right, so let me see if anything else is there. I do know it has 4 sides. 4 sides means it is a quadrilateral. All right, so now I've got square and quadrilateral. I didn't go in order yet because I'm just kind of seeing what shapes I see first. I know it's a square and I know it's a quadrilateral. Let's check a few other things. If it's a square, all the sides are the same length. Sorry, my cat is in the background crying for its food. So now we have 4 sides the same shape. That makes this a rhombus because all 4 sides of the quadrilateral are the same. And lastly, I know that these are right angles. If I have a shape that's a quadrilateral and has 4 right angles, then it is a rectangle. Perfect. So it actually is all of these things. And as we've come to know, the square is the most special shape. It is a rectangle, it is a rhombus, it is a quadrilateral, and of course it is a square. Okay, continuing on. Divide each shape into the number of equal parts shown. Then write the fraction that describes each part. Okay. So, if I want to divide this into 3 equal parts, really the only 2 ways to do it are to do this. That's 3 parts, 1, 2, 3, and that means that is 1/3, 1 equal part. The fraction that describes each part is a third. That is our unit fraction. And I could draw this way as well. I could go this way and divide it into thirds. As for the hexagon, this hexagon, really, I kind of need to start in the middle and draw for triangles. Really what I'm doing is going from point to point, and I create 6 equilateral triangles. There are all acute angles in there, and this would be 1/6. So I'll keep that as 1/3. Now this is the one where we can draw it in several different ways. The easiest way would be to put this and divide this way, this way, this way, and this way. I now have 8 equal parts. This is divided into 8ths. I've taken my shape and made 8 equal parts. However, I could also do this way. I could divide it in half, divide this in half, and then divide all these in half again, or try to do them in half. I would have 8, 1, 2, 3, 4, 5, 6, 7, 8 equal parts. All of these are smaller this way. I could do the same thing going this way. This is going to be a little more difficult to draw because my lines are thicker, but I do want to show you that it would work in this direction as well. These all would be 1/8. So you get to choose, most likely the easiest way of all, and for sake of, well, ease, right there, 8 equal parts. And the last one we're going to do right now, number 9. Han drew a triangle with one angle greater than a right angle. So which of these could have been that triangle that Han drew? He drew a triangle with one angle greater than a right angle. Well, I see here 3 angles less than 90 degrees. If he had one angle had to be greater than a right angle, then there is no way this could be the triangle that Han drew. Here I have a right angle, which is totally fine to have in there, except if I have a right angle and I have 2 more angles, well, these are both less than 90 degrees. This is 90 degrees. It is not greater than 90 degrees, so this cannot be the triangle that Han drew. Here's one with 2 small angles and an angle that definitely appears to be bigger than 90 degrees. Very slightly, but it does seem to be larger. If I put a piece of paper up to it, I could probably test, and I could probably see that, okay, there's my line, and this one is a right angle would come off at like this. This angle would be the right angle right here. This one seems to be bigger. So this one is definitely a possibility. And I can tell by looking, oops, I've mismarked all my things. Yes, this could be possible. And this one also has one angle that could be larger than 90 degrees. All right, this takes care of our first portion of our review. I will do the second portion in another video.